In this video, we look at questions where the denominator has more than one root. For example, the denominator of an algebraic fraction has repeated factors in the denominator. Alright, as always, before we get to algebraic fractions, I usually use numerical examples. If you were given 11 over 25, how would you split it up into smaller fractions? One, one way of thinking about it is you could have written it as 1 over 25 plus 1 over 25 plus 1 over 25. You would end up with 11 fractions. You might think to yourself, well, how about, alright, you could split up 11 over 25 as 2 over 25 plus 2 over 25 and so on. That would still wouldn't be simplest form. The correct way to deal with it is actually to think about factors of 25 and write 25 as 5 times 5. I would think of it as, let's pretend that we have a factor of a over 5 and b over 25. Now, which of these fractions is a larger fraction? Actually, the one with the lower denominator is a larger fraction. So you would say a over 5 is more significant than b over 25. Therefore, you write your partial fractions like so, and you deal with it with that like so. Okay, so I'm not going to go through splitting up a numerical fraction into partial fraction, but I'm trying to get you to understand that this fraction where factor of 25 is root of itself is bigger, and therefore we have to start with that because that would be the more significant fraction. What if you had to split up 5 over 8? I would suggest you try writing 8 as its factors. 8 has factors of 2, 2 and 2. I would start writing a over 2 plus b over 4 and c over 8 and go ahead with that. The final answers are something like so. We're not going to go and perform partial fractions on numbers, but the algebraic fractions work the same. In this example, you have the denominator x plus 1 and x minus 5, which is squared. This is called a repeated root because factor of x minus 5 has a square on it. Therefore, we're not going to just jump into x minus 5 squared. Before we get there, we have to include this factor of x minus 5 alone, because this fraction would be a larger fraction than c over x minus 5 squared. Okay, so let's go through this example and finish it and see how it's done. As always, you think carefully. If you were adding these three fractions on the right, how would you deal with it? A would have to be multiplied by x minus 5 squared because the denominator has to have x minus 5 squared. Okay, so these are the roots that are missing. Okay, so we said that factor of x minus 5 squared is missing from A. So we will write the numerator as a multiplied by x minus 5 squared. The numerator of b has already a factor of x minus 5, so the factors that are missing from numerator of b are x plus 1 and single value of x plus x minus 5. Why? Because we only need to have one more factor of x minus 5 in the denominator and x plus 1 in the denominator. What's missing from c, the fraction that has c on top of it, is simply just x plus 1. We don't need to multiply it by x minus 5 at all, so that these fractions will have the same denominator. Okay, so this is how you deal with this kind of problem. You write b times x plus 1 and x minus 5, and you would have c only multiplied by x plus 1. Now I'm going to leave out the denominator because I know the numerators are going to match. I don't need to match the denominators. So that expression equals to 3x squared minus 4x plus 2. Now, with elimination, we can assume that x equals to 5. So this bracket and this bracket will cancel away. What we end up with is c multiplied by 6 on the left, and on the right, factor of 5 will mean that 3 is multiplied by 25, and we take away 20 and add 2 to it. 75 minus 20 is 55. 55 plus 2 is 57. Now 57 doesn't divide by 6 straightforward, but it does give us 19/2 or 9.5. We can write 19/2. Then for elimination of this bracket x plus 1, we can pretend that x is taking a value of minus 1. If x is negative 1, this bracket and this bracket will cancel away. So we're left with a multiplied by minus 1 minus 5, which is a negative 6 squared. That's 36a on the left. On the right, we will have 3 multiplied by negative 1 squared minus 4 times minus 1 plus 2. That means that we have a 3 plus 4 plus 2. That's 9. So we have 36a equals to 9. Therefore, a must be 9/36, which is simply a quarter. Finally, we've used all the factors that all the numbers that would eliminate the brackets. But what do we do to figure out b? Well, doesn't matter. We can use the facts that we have found a and b, and now we can use it in our calculation. We can say that x equals to 0. After all, x can take any value. So if x is 0, we have 25a. We will have 1 times minus 5, which is negative 5b, and 1c. On the right side, when x is 0, we'll have simply 2. Okay, so the fact that we know what values a and c are will help us calculate the value of b. We know that a is a quarter, so 25/4 plus or plus c, which is 19/2, minus 5 lots of b should equal to 2. Okay, take your time and work out the value b. That means subtracting these two fractions from 2. Pause the video and finish it off, and then check your answer with mine. b is, well, the effect of subtracting those two fractions from 2 will give us negative 55 over 4, and dividing both sides by negative 5 will leave us with 11 over 4. So how would we write these answers in in our final answer? The value of a goes over x plus 1. So rather than writing a quota on top of x plus 1, I'm going to bring the 4 down next to the denominator. This is the same as having a quota on top of the fraction. Value of b is 11 over 4. I'll leave the 11 on the top and bring the 4 down next to x minus 5. Notice I'm glancing up here and looking at b goes on top of each factor. Finally, we'll have c to be 19 over 2. So I write plus 19 over 2 and open a bracket, x minus 5 squared. Okay, so this is how you would write if you ended up with fractions rather than integers for values of a, b, and c. Let's look at another example. In this example, we've been asked to calculate and write this as partial fractions. Once again, make sure you repeat factor of x plus 1 as a singular term and as a square term in the denominator. Okay, so common mistake that students make is not writing this first fraction and simply going to x plus 1 square in the denominator and just write two fractions. Well, a needs to be multiplied by only a factor of x plus 1 and 2x plus 1. b needs to only be multiplied by factor of 2x plus 1. And c only need to be multiplied by x plus 1 square. Finally, we can leave the denominators alone and group like terms together with the denominator. We only need to match up the numerators here. Therefore, 11x squared plus 14x plus 5 ends up to be equal to this expression. Now we get to solving for a, b, and c. You can choose any value of x you like as long as you substitute it in the left and right brackets. That's all that matters. X equal to negative 1 will eliminate this bracket and this bracket. So we only left with this section here because 0 multiplied by anything else will make it 0. So we have negative b to be 2, therefore b is a negative 2. Now we can take value of x to be a negative half. How did we come up with it? If you set up 2x plus 1 equal to 0 and solve it, you end up with x being negative half. So to eliminate this bracket and this bracket, make them 0, we take x to be minus half and substitute it in the left and on the right. That would give us value of c to be 3. Finally, we can choose yet another value for x. We can pretend x is 0. Since we know the value of b and c, that will help us to perform the calculations. So we will have a plus b plus c equals to 5. Using the fact that we know b and c are negative 2 and 3 will help us calculate the value of value of a. So finally, we write these three answers by glancing at the top and looking at what values goes where. 4 needs to be on top of x plus 1, minus 2 goes on top of x plus 1 square, and so on. I hope you found this video helpful. I'll see you in the next section.